Hey everybody, Mr. Bullock here, and this lesson's on evaluating square roots and cube roots. Okay, so it's for our new integrated 1 series. So here's our Common Core stuff, and so basically what's a radical sign and what's the difference between a square root and a cube root? And why can't you square root negative numbers, but you can cube root negative numbers? And we'll explain that in this lesson here. So this is evaluating square roots and cube roots. So first of all, let's list the first 12 perfect squares. So this 1 is a perfect square because it's equal to 1 squared. Well, what's 2 squared? 2 squared equals 4. So 4 is a perfect square. Okay, 3 squared, 3 times 3 would be 9. You guys get the picture right here? So then 4 squared, 5 squared, 6 squared, all that right there is 16, 25. Here's 6 squared. 7 squared is 49. 8 squared is 64. These are things that if you don't know, try to get them in your memory banks here. These are things that will help you tremendously for the rest of your math if you know some perfect squares all the way up to 12 squared. Okay, so 9 squared is 81. 10 squared is 100. 11 squared is 121, 12 squared is 144. And I know if you don't know them, you're thinking, I'll never use them again, but you will in your math classes, you guys. It would help you a lot. And then, so especially like in this lesson and the next future lessons, let's list the 7 perfect cubes. Okay, so cubed is like 1 cubed, 2 cubed, 3 to the third, 4 to the third, all the way up to 7 to the third. Okay, 1 to the third, well, that's easy enough. 1 times 1 times 1. Okay, 1 time, that's easy enough. I don't need to explain that. 2 times 2 times 2 is 8. Okay, don't think it's 6, you guys. 2 times 2 is 4. 4 times 2 is 8. 3 times 3 is 9. 9 times 3 is 27. 4 times 4 is 16. 16 times 4 is 64. Okay, 5 times 5 is 25. And then another times 5 is going to be 125. Here, I did that over here. 25 times 5. Okay, 5 times 5 is 25. So there's the 5, carry the 2. 5 times 2 is 10, plus 2 is that 12 right there. Okay, 6 times 6 times 6 is 216. Okay, that's 36. There's my 3. 6 times 3 is 18, 19, 20, 21. So 216. Okay, 7 times 7 times 7 is 343. Okay, now to be honest with you guys, I sometimes forget about 216 and 343, but it just takes a little bit of quick multiplying, 49 times 7, to figure out which one that is right there. Especially after this lesson, you should get pretty good. Okay, square roots, you guys. It kind of goes like this. If b squared equals a, then b ends up being what's called the square root of a, or b is the square root of a right here, okay? So if I said, what's the square root of 1? It would be this one. What's the square root of 4? It would be 2, because remember, if 2 squared equals 4, okay, then 2 is going to be the square root of 4. All right, so let's see. What's the square root of 121? It would be 11 right there. Okay, so the square root of all these red numbers are going to be all these black numbers that are being raised to the second power right there. Okay, so notice our b squared will always be positive, whether b is positive or negative. So if, like if I squared like negative 2, you guys, negative 2 times negative 2 is a positive 4. B squared is always positive, so since b squared is always positive, then a must always be positive right here. Okay, so the square root of a must always be positive also. Okay, so I can never square root a negative number. All right, so recall all these perfect squares right here. The square root of 36 is 6. See, here's this. Square root of 36 is 6. Square root of 81 is 9. So it's basically saying what number times itself, that's this number in here gives me that. So to be inside a radical, it's going to have to find out what number times itself gets me that number inside the radical. There's a couple other ways I'll show you too. Cube roots, you guys. If b cubed equals a, then b is the cube root of a. Okay, and you write it like this. It looks just like the square root sign, but there's a little 3 there. It means the cube root right there. All right, so b cubed, if I cubed a number, it can be both positive or negative depending on what b is. So for example, 2 cubed is equal to 8. Negative 2 cubed is negative 2 times negative 2, which is positive 4. 4 times negative 2 is negative 8. So it just depends on, so this can be, b cubed could be positive or negative right here. So A could be also positive or negative. The cube root can also be positive or negative. Okay, this number here, this says, what number times itself 3 times equals this number inside of here? That's what this little 3 right here says. So 2 times 2 times 2, so this equals 2 right here. What number times itself 3 times equals negative 8 right there? Well, negative 2. It shows it right up here. So the cube root of negative 8 is equal to negative 2. Okay, so recall all those perfect cubes right here. All these dark blue numbers are perfect cubes. This is 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, 6 cube, 7 cube. Those are all nice perfect cubes. So the cube roots of these numbers, the cube root of 27 is this 3 right here. The cube root of 64 is this 4 right here. The cube root of 343 is this 7 right here, okay? So it's asking what number times itself. And also, you guys, the cube root of negative 125. Well, that's negative 5 times negative 5 times negative 5, which is negative 5. Cube root of negative 216 is negative 6. Okay, so you can cube root negative numbers. You can't cube root positive numbers, okay, or you can't square root negative numbers. I'm sorry. So evaluate each. So here's so let's evaluate square root of 64 plus the square root of 121. Okay, here's the square roots that we over here. Square root of 64 is 8. The square root of 121 is 11. Again, try to know these ones right here, you guys. So this is going to be 8 plus 11. 8 plus 11 is 19. Okay, let's try this one here. Square root of negative 9. Okay, remember, we can't square root negative numbers. We can cube root negative numbers. We can't square root negative numbers, so this one does not exist. And I'm just going to put DNE for does not exist, okay? All right, the cube root of negative 27. Well, that's equal to, remember, here's the cube root of 27, and the cube roots, you can get a negative, so this one's going to equal negative 3, because negative 3 times negative 3 times negative 3 equals negative 27. All right, the cube root of 64 plus the cube root of plus the square root of 144. Okay, let's get my cube roots. The cube root of 64 is equal to 4. What's the square root of 144? All right, that's 12. Okay, so I get 4 plus 12 is 16. Okay, how you guys doing? Hopefully well. Okay. All right, 2 times the square root of 25. 2 root 25, that's how we'd read that mathematically, is the same as 2 times the square root of 25, and the square root of 25 is 5. 2 times 5 is 10. Okay, here 3 times the square root of, or 3 square root 36 plus 4 squared. Okay, well, 3 square root 36 is 3 times the square root of 36, and then here's my 4 squared. 4 squared is 16 right there. And then square root of 36 is 6, so 3 times 6 is 18, and then 18 plus 36 is 54. Okay, 3 times 4 minus the cube root of 8. Okay, let's do 3 times 4 first is 12. The cube root of 8 is 2. 12 minus 2 is 10. Okay, 7 root 49 minus the cube root of negative 27. Okay, so square root of 49 is 7. Square root, or the cube root of negative 27 is negative 3. Okay, so here 7 times 7 is 49. And then minus a minus becomes a plus. Remember, we add the opposite, so 49 plus 3 is 52. Okay, kind of tricky. Okay, here's some more here. Okay, let's do the exponents first, you guys. And I'll do the exponents and square roots. You do the same things. Radicals and exponents are same thing. Do those first. Okay, so here's 4 squared, 5 squared, and the square root of 36 right there. Okay, now I'm going to simplify 16 minus 25. 16 minus 25 is negative 9. Okay, now I go to negative 2 times negative 9, and negative times negative is a positive, so 18 plus 6 is 24. Okay? All right, so write each number as a repeated multiplication, circle each pair or triples, depending on if it's a cube root or a square root. Square root is a pair. And pull out 1, multiply the factors together. So for example, square root of 81, you guys. Okay, well 81, and hopefully you guys know is 9, but the reason why it's 9 is because it's 3 times 3 times 3 times 3. Here's 9 right here. This will help us more in the next lesson after our test right here. So we won't get like the square root of 81s, we'll get square roots of the other ones that aren't perfect squares. All right, so we're going to circle the pairs. So the pair of 3's and a pair of 3's brings me, so here's this one. This one's from this pair. This 3's from this pair, and then you multiply them, and that's why it equals 9 right there. Okay, the cube root of negative 125. Well, that's negative 5 times negative 5 times negative 5. And this cube root says I'm going to pull out 3 on the inside. That brings 1 on the outside, okay? So 3 of them on the outside is going to bring 1 of them on the, 3 on the inside brings 1 on the outside. Okay, oh, I hope that makes sense, you guys, and take care.